So we're looking at confirming continuity over intervals. Basically, part of AP calculus or any calculus that you're dealing with. So what we're looking at here is we want to determine the domain of these function that we have on screen. So let's just see how much we can do here. All right, so first and foremost, we have g of x is equal to the square root of 12 minus 2x. Because we're looking at a square root function here, then we must ensure that that radicand, which is that expression under the square root, and it's 12 minus 2x, it has to be greater than or at least equal to 0. So let us solve for x, right? Let us solve for x right there. So let us subtract 12 from both sides. So I do have negative 2x, which is greater than or equal to negative 12. So here I'm going to divide by negative 2. Whenever you divide by a negative number, you have to flip your inequality. So it becomes less than or equal to positive 6 at this moment. Now, so this is actually my domain. My domain has to be less than or equal to 6. So if I'm going to write this in interval notation, it means then that I'm coming from negative infinity to 6. And I'm going to put a square bracket here because 6 is a part of that domain. All right. So that's number one. Let's take a look at the second example here. F of x is equal to x minus 7 all over x squared minus 9x plus 14. What I'm going to do for this one first, I'm looking at the denominator here, right? Our denominator cannot be equal to 0. If our denominator is 0, we are having a problem. So I'm going to try to factorize that denominator. My denominator, which is x squared minus 9x plus 14, this cannot be equal to 0. So if I factorize this, what do I write there? If I factorize this, I'm actually going to have x with a minus 7, x with a minus 2. This can't be equal to 0. So basically, if I do these, we're saying that x cannot be equal to 7. Also, x cannot be equal to 2, right? So with that said, I need to have this is actually the response. So we will be coming from negative infinity to 2, union from 2 to 7, union from 7 to positive infinity. So basically, we are representing the domain. So this would have been the domain, which when you represent it in interval notation, it would have been that. All right, so let us take a look at the third one. The third one is a log problem, right? So it says here that f of x is equal to ln 2x plus 5. Be advised that the argument here, 2x plus 5, has to be greater than 0. So we have to remember that when we're dealing with logs, this argument here must be greater than 0 because we cannot find the log of anything less than 0 or 0. So from here, let us solve this. Let us minus 5 from both sides. I'm looking at 2x, which is now greater than negative 5. When we divide both sides by 2, our response is that x is greater than negative 5 over 2. All right, so let us represent this. That's using inequality. Let us use our interval notation now. It means then that we're coming from 5 over 2, and we're going to head to positive infinity. The fourth problem, we have h of x is equal to 5 minus x all over 5 minus the square root of x. All right, there are two things here. Our numerator is good. Our denominator, though, we are looking at the fact that 5 minus the square root of x, this cannot be equal to 0. So that is our first thing that we want to take a look at. Let us solve for x here. So let me just minus 5 from both sides. So basically, negative the square root of x cannot equal to negative 5. Let us say I multiply through by negative 1 then. We're looking at x squared cannot equal to 5. So if I square these, then x cannot equal to 25. So we're looking at the fact that x cannot be equal to 25. That's one. The second thing that we have to pay attention to is the fact that we do have a part of our denominator, which says the square root of x. We have to be conscious of the fact that x has to be greater than or at least equal to 0 because we cannot find the square root of a negative number. So what are we looking at? We're looking at two cases here. Case one, we're saying that x cannot equal to 25, and case two, x has to be greater than or equal to 0. So let us represent this using interval notation. So it means then 0 is a part of the idea. So I'm coming from 0 and I'm going to go to 25, but we cannot equal to 25. So I'm going to use a parentheses here, and then we're going to union 25, and then we're going to add to positive infinity right here. So this would have been my domain, right? The responses that we actually can take. Let's take a look at the fifth problem here. For the fifth problem, we're looking at a rational function with a square root at the top of our rational number there. So let us take a look at this. First, I will isolate this part that says, so I'm looking at this part, t minus 1 has to be greater than or equal to 0. Then if we solve that, adding 1 to both sides, then one of our solution would be that, hey, t is greater than or equal to 1. So we could mark this. That's one of the responses that we definitely use. Now, at the denominator, we want to factorize this very quickly. My denominator, I could have represented it as t minus 8, t plus 6. So that would have been the factor there, which means that t cannot equal to 8. Also, t cannot equal to negative 6. So those are my constraints here. All right, so my domain would be that. So let's put everything together. If you look, we can eliminate the 6 because remember that t has to be greater than or equal to 1. So we're going to have to start at 1 because t cannot be equal to negative 6. We know that. But at the same time, we have to start at positive 1 to satisfy everything. So in this case, we're coming from 1 and we're going to go to 8. That looks like an infinity. Let me write it down. So we're going to go to 8 and then we're going to union from 8 and we're going to head to positive infinity. So this would have been my domain right there. So let's take a look at the last one. For this last one here, it's quite similar to one that we have done before. My numerator is perfect, so I just need to focus on two things. The square root of 5 minus x, which is my denominator, cannot equal to 0. So if we square this and square that, we'll have 5 minus x cannot equal to 0. Switch sides with this, so 5 cannot equal to x. So 5 cannot equal to x, or x cannot equal to 5. Same thing. All right, so let us put a mark on that. All right, so we have that. X cannot equal to 5. Also, this same part here, because it's under the square root, then we're saying that this part right there has to be at least greater than or equal to 0. So if we solve this, we're saying that, hey, 5 has to be greater than or equal to x, or you could say x is less than or equal to 5, right? So on seeing that, we're looking at the fact that we're coming from negative infinity to 5, but 5 cannot be a part of the solution. So we're coming from negative infinity to 5. But I have to use the regular bracket, all right, not the square bracket. Even though this would suggest, but we have to remember that this is a part of the solution. So 5 cannot be a part of our response. We're going to stop there for now. See you next time.